The first concept we need to make sure we have it clear is that blockchain is a technology and Bitcoin is an asset. A technology is like a tool. For example, the internet is a type of technology that helps us communicate across the globe. While a computer is a physical asset that has some intrinsic value due to the materials on how it was built and the perceived value in the form of its usability. Let's explore some additional concepts. A digital asset is something that is not material, per se is digital, and holds a value through its perceived usability. For example, an app on your phone. You probably have a certain amount of apps, and let's say you pay $2.99 for one of them to be able to download and, let's say, track something, save you time, maybe it's convenient, give you some entertainment, or some other type of value. With that, Bitcoin is a form of digital asset. The same as more than thousands of tokens available nowadays. For example, Ethereum, Dogecoin, Shiba Inu, Floki, just to mention a few notable ones. A token is, for the purpose of simplicity, a digital asset. It's basically a way to measure reward or pay for a transaction. If you think about the game Monopoly, the Monopoly dollars are a form of token and they have some value and is accepted in the realm of the game. A cryptocurrency is a token that have a counterpart value tied to a currency. For example, the dollar. It's called crypto because the nature on how this token is created comes from a cryptographic theory. If you are curious on how exactly that works, stay until the end because I will have an additional resource and videos explaining deeper into this concept. But for now, this is as much as we need to know. For that, we're in the same page with different terminologies. So let's go back to what is blockchain. Blockchain is from the word that comes from blocks and chain. A block is a piece of something. Let's imagine we have a personal journal where every day we put our thoughts and what we learn or how we feel or anything you want to write about yourself. Each page on that journal is a block. A chain is when a group of something is joined with a group of other things. In the case of a journal, all pages are joined together in a specific order through the spine of the journal. What is interesting about blockchain technology is that it's based on three main aspects. First one is immutability, meaning that once it's written down, it cannot be changed or delayed. Second is decentralized. That means that there is no central authority or organization that have unique access to the data. That data is in multiple locations simultaneously. And third is able to make decisions in a consensus. There is a, let's call it for now, intelligent code that will verify the transactions. Probably you already guessed. That doesn't sound new, right? Indeed, blockchain technology is not new. What is new is the combination of existing technologies to create something different, which I will explain you a little bit in detail later. So blockchain is a combination of cryptography, peer-to-peer networks, and programming, or coding, if we can call it that way. That's basically what blockchain is. So why all this hype now with blockchain if it's based on something that was not completely new and already existed? Now, here's where I tell you to stick to the end, where I'm going to show you a quick demo on how exactly this works. And of course, if you like this video and it's helping you better understand these concepts, please like the video and subscribe to my channel so you can learn more a little bit about this crypto world. Going back, when we look at our human nature, we are inclined to be productive, meaning we try to always achieve things faster. That's why there's a lot of research and development right now on self-driving. Outside of being an innovative idea, it can save us a lot of time. By combining these technologies, meaning cryptography, peer-to-peer networks, and programming, into this new technology called blockchain, and of course, depending on the application, it can help us create automation processes for companies, it can help create transparency of data, it can help secure and efficient forms of communications in a way that it was not done before. In other words, we can do things faster and save time. We all know that time is money, and that's where most of the incentive of this technology is currently coming from. A residual portion of the creation of the technology are tokens. Tokens are used to incentivize the transaction within a blockchain. The same way we give a tip to a waitress when we go to a restaurant. When these tokens are tied to a currency, for example the dollar, then any type of transaction that may happen in the blockchain can be rewarded. In other words, anyone can pretty much print money. Because tokens or cryptocurrency is tied to a paper money, then it can also be traded. As such, a new form of crypto trading is also established and comes from the result of this new technology. Of course, that's something I will explain in another video. Back to blockchain. Let's say I am a company collecting a check from a customer. I need to send the invoice to the customer. Let's assume, just for simplicity purposes, the internet was not yet created. So I will write down an invoice and then go to the postal office and send it to the customer. Now, how could I know that that invoice made it to the customer so he can pay for that? Well, there are a few options, right? The easiest one is I can just go directly to the customer and ask them about it. But what if I don't trust him? I cannot trust my customer. How do I know if he says he have not received it, if that's actually true? In that case, well, we can ask the person who delivered the invoice. But most likely the postal office hires many people, so it will be hard to know who to ask. And the other one is that I can go directly to the postal office. Let's say I trust them in their process and they are correct, and they tell me the invoice was delivered, which is something that has been working there for many years. Nowadays, we just go to any postal office and ask for a tracking number, and we know it was delivered or not. Well, there are some cases that sometimes it's not correct, right? Now, let's say I am very skeptical and I don't really trust anyone. So in that case, how could I know that that invoice was actually sent to my customer? In this same example, let's say now that the postal office is no longer an organization, but a group of people who just deliver mail. When I send my letter, the person who collects it will have a journal where he writes who's the sender, the receiver, and the content. To determine the person who will collect the mail and deliver it, let's say mathematical problem is given to all of them, and the first one who completes will be the one who's going to be delivering my mail. Once it's delivered, he will add that into the journal. The journal is also synced across the other mailmans. So just from there, I could go to any of them. It doesn't matter who's the one who won that mathematical problem and delivered the invoice, and ask them if the mail was delivered. Now, what happens if my customer have access to that journal and change its information, right? Because that would be another issue. Or what happens if not they just change, but probably they say, hey, you owe me $10 and they change it to be only $5, for example. So to solve that, on top of the information about the sender, the receiver, and the message, there will be what is called a hash number. Now, I don't know if you probably have heard about a hash number or not. A hash number is basically a mathematical calculation of, let's call it a string of things. The most typical place where we use this concept of hash is actually on a credit card. We use credit cards nowadays almost to buy anything, right? So if you look actually at your credit card, and here's also a website that explains a little bit further how that mathematical calculation is performed. But basically the last digit of the credit card is the result of a mathematical calculation of all the previous numbers. So with that, if I were to, let's say, invent myself some random numbers to perform a payment, the payment processor can do this calculation really fast and realize that my credit card number is actually not correct. So going back to our example, the hash can identify that the content of the message is indeed the original one. So let's say in the journal of the mailman, we don't just add the sender, the receiver, and the content, but we also add the hash of all that previous information. With that, if the receiver, for whatever reason, changes the message, its hash will not be the same as the one when we send it. All that basically put into a blockchain. Each page, meaning a block and a change, each page of the journal will have the hash from its previous page. So now we are tying that up into, let's say, a chain And each of the pages, if it's removed or anything, will be noticed by the change because all of those ones will have that hash from the previous one. Okay, I know that you've been waiting to see a real demo that I told you before. I've been talking about all these few minutes with all this theory, all these examples. So why don't we just jump in? Let's take a look exactly into an example, a hands-on example, how blockchain works and how this is it. Okay, let's jump into this example. Let's take again the example of the postal office. And this is how basically a blockchain is represented. Each of these boxes is a block, and basically the junction of all these boxes are the chain. So all of this is coming from Anders Brauntwort. He is a technologist. He used to teach in different universities across the US. And he basically developed this sort of demo to be able to visualize what a blockchain is. So let's go back again to our example, and don't care too much about these nouns. This is just like a random number. It's just for the crypto process. But as you can see over here, you can see the hash number. So right now, this hash number is, again, that mathematical calculation. As you can see, is very long and complex. The result is not the calculation. We don't know what's behind that calculation. But we can see over here the previous one, because this is our first block. There is no previous one. That's why we have 0. But if we look at the next block, block number 2, the previous one that is over here, so it ends in 7CF, is the same one that we have over here, 7CF. And then it creates another hash over here, and that hash will be back again over here on the third block, again creating that chain. So let's go back over here, and let's say my data is saying that this is the sender, so I'm the one who's sending it, and then the receiver is, let's say, my good old friend, oh no, in this case a company. So the receiver is my customer called John. And we decided to write down a message. Sorry for that. Let's just copy and paste it. I have it over here, so I'm waste time inputting it. So let's say we have an invoice number for the amount of $10. As you can see, every time that I write down things over here, the hash number changes. Because again, is the calculation of all this data and let's say this random number. So once I have it here, this is the message that I want to put over there in my blockchain. I'll mine it. Basically, in other words, I'll write down this into this blockchain. Right now, what I'm writing and typing is not yet there. And once we click mine, let's say now it's going to be in that, let's call it blockchain. So that means that if I come over here and change it, you see everything else going to be changing again. So going back to the original one, you see if I add something, it becomes red, because the hash number will change. So now the blockchain will know that, hey, something happened over there, right? So we'll go back to our original one. And then let's say, for example, John sends the check back. So we have here John, and then the receiver will be myself. And then the message or whatever it contains, let's say is the check for $10, right? Just for simplicity purposes. And click mine over here, so it's written down in the blockchain. And you can see over here, my hash from the previous one ends in 924 over here. And again, we can see over here that the previous hashtag also ends in 924. A new hashtag is created, so whenever we have the next block, we'll be using this hashtag and so on. And basically, that's the simplicity of a blockchain. Again, how new is this technology? In reality, not much. Most of this process happens when you, for example, send an encrypted email or have a chat conversation over an encrypted app. The encryption program is called Pretty Good Privacy, or PGP, and it was invented in 1991 in combination with P2P networks that was invented before the internet and probably well known after Napster. Of course, all of these will be topics for another video. Although its application in today's interconnected world makes blockchain the future of data processing, communication, and transparency of information. If you think this video was useful to better understand what blockchain is, please like this video. And if you want to learn more about blockchain, cryptocurrency, and trading, subscribe my channel. We'll see you on the next video.